Hello and welcome to this episode of Math with Martinez. This is part 2 of our video where we are solving logarithmic equations, but we are now looking at type 2, which is where we will no longer have log equaling a log, but log equaling a number. So you can see that there are 3 steps here that we're going to be following in order to solve each of these equations. And then we're going to definitely, like it says in step number 3, always check for any extraneous solutions. Those extraneous solutions, again, are values that make your equation false or that cause an error when you substitute them back into the original equation. So let's go ahead and begin with our example 7 here. We're going to follow these 3 steps in order to solve this type 2 log equation. Step number 1 is to condense and isolate our logarithm. Well, we have been practicing that condensing procedure and now are working towards mastery at it. So looking at this side, there is only one logarithm. That's what it means when it says condense, that you should have only one log expression. And we do. So we are done with step number 1. That's already done. We can go ahead and begin step number 2, which is to rewrite the equation in exponential form. Remember that if you have something that looks like this, log base b of a equals, we'll just call it c, then when you write that in exponential form, it's going to be the base of your exponent is also the base of your logarithm, so b, and then it would be to the power of c, right, following our little looping trick, and then it would equal to a. So looking here at example number 7, when we rewrite this, the log base is 2, so in exponential form, it would also be 2. It's going to be raised to the power of 7, and then equal 3x minus 4. That's that other side of my looping conversion trick there. Okay, so now we've got step number 2 done. Now we're moving on to step number 3, which is to solve and check for any extraneous solutions. I'm looking here at the left side. I can simplify 2 to the 7th power, grabbing my graphing calculator. Help me figure that out. That is 128. And there we go. Next step would be to add 4 on each side. So when I do that, it'd be 132 equals 3x. And then dividing each side by 3 is going to give me 44. And there we go. Cool deal. And just so you can see here, my little check on the side, what I mean by checking is plug it into the original and see if it makes it true. When you take the 3 and then multiply it by that 44, subtract 4 from it, all of that should be equal to 7. Is it in fact equal to 7? When you take this entire side, oh my goodness, that's cool. I didn't know I had a ruler feature now. Okay, so is this whole side right here, when you plug it into your calculator, does it equal to 7? It sure does. So that means that this is, in fact, my solution. There we go. Let's do another one. Our first step in this next example is going to be to isolate and condense our logarithm. And I'm noticing here that my log isn't actually all by itself just yet. What I'm going to want to do is take and move this constant to the other side. Now it's ready. Now we've got our logarithm condensed and isolated. So we move on to our next step. Step number 2 is to rewrite it in exponential form. So that's 6 to the power of 2 equals w plus 7. And then we are at our final step, which is to go ahead and solve and check that your solutions are not extraneous. So 6 squared is 36. And then to get w by itself, I'm going to subtract 7 on each side. That's going to give me 29. All right, and then the check is just found by taking and plugging it in and making sure that when you take 29 plus 7 inside the argument of your logarithm and subtract 5 from that, it should equal -3. Does that happen when you take this entire side here? It sure does. So that means that 29 is, in fact, my solution. All right, now let's switch things up a little bit here. We are looking at a logarithmic equation, and like I said, we must have only one log expression. Looking at this one, I've got 2 of them. So this is the moment where now it's time to condense. Because we are adding, that means we are going to take and multiply our arguments together. So that looks like log base 4 of 2v plus 3 being multiplied with 2v minus 3. So I need to take those binomials and multiply them together. I'm going to grab my little area model here. And I'm multiplying 2v and a positive 3 and a 2v and a negative 3. Okay, so actually all that's going to give me is, because the linear terms combine to be 0, this simplifies to log base 4 of 4v squared minus 9 equals 2. Okay, condensed, isolated. Now we're ready to go ahead and rewrite it in exponential form. So that's going to be 4 to the power of 2 equals this expression. 4 to the power of 2 equals that expression. 4 squared is 16. And now let's go ahead and solve. I will want to add 9 on each side. That gives me 25. And then divide by 4. Well, it doesn't divide nice and evenly. And then take the square root on each side. Let me finish my work over here. That gives me 5 over 2 equals v. Technically, it would be both plus or minus, but when you take and plug in that negative 5 over 2 into the original, I'm giving you kind of like the cliff notes here because we are on a timed video. If you take and plug in the negative into the original in your checking, what would happen is you would get an error statement, because if you're ever working with an argument that is negative, like when you simplify everything, when you would take and plug this in, it would be 2 times a negative 5 over 2 plus 3. That's negative 5 plus 3. That's negative 2. If you take log base 4 of negative 2, That is an error. You'll get an error statement. So the only possible value is actually the positive 5 over 2, not the negative 5 over 2. So let me actually write it like this. V would be both. It could be positive or negative 5 over 2. But what I'm going to show you here this one is no good. Only this one works when you do your checking. Okay, so there we go. We've got one final example here, and it's a lot like what we just saw, where we've got two logarithmic expressions that need to be condensed. So, how do we condense them? We're separating these logarithms by addition, so that means that what we're going to need to do is take and come in here and multiply them together. So I'm going to grab my little area model. And I have n and a negative 3, n and a positive 1. Okay, so this is going to be a trinomial. I'm going to have n squared minus 2n minus 3. That all equals 5. Okay, now we're ready to convert to exponential form. That's 2 to the 5th power equals that. And now let's go ahead and simplify and solve. What do we get here? 2 to the 5th power is actually 32. And we want to solve this actually now by factoring, because I don't just have the ability to solve by taking square roots. We're going to bring that 32 to the other side, 32 to the other side, so that it's set equal to 0, and we can factor. When we do that, it's going to be a negative 35. So let's use our area model again. Love the area model. We use it all the time here, don't we? Okay, 35. That's got to be a 5 and a 7, and that 7 must be the negative 1, so that we have a negative 2n. So that means n plus 5 equals 0, n minus 7 equals 0, and n is either negative 5 or a positive 7. Now, thinking back to what I said earlier, which one of these is going to be valid when we plug it in? If I plug in my negative 5, what's going to happen here in this first logarithmic expression? I'm going to be taking log base 2 of a negative 8, and I can't take a log of a negative argument. So what that means here is that this does not work. This negative 5 will not be a valid response. It is an extraneous solution. So the only value that makes my statement true is 7. So there you guys have it. That is solving type 2 logarithmic equations when you have logs equal to a number. It requires us to follow these steps, and what's really different here is that we have to rewrite them in exponential form. We get stuck in log form. We can't do anything more, so we convert it, and then we're able to finish solving. So that's all for this video. If you guys had any questions, would you please take a moment and share those now? And until next time, stay fired up.